Hello, so today we are going to go over Unit 4, Lesson 8, Acceleration. So basically when we look at the change in velocity over time, so if you look here we have distance in meters, and then we have time in seconds. So as we plot these different points here, we can make a line and show that there is an increase in velocity over time. So each time you take a step, you are changing the velocity of your body. You're probably most familiar with the velocity change of moving buses or cars, so as you're driving and you're increasing that speed. The rate at which velocity, or speed, or direction changes occurs is called acceleration. So acceleration is the final velocity minus the starting velocity all over time. So the change in velocity is, of course, is your final velocity minus your starting velocity. So you can just write that as acceleration is the change in velocity over time, or you can call it delta v, so that change in velocity. So here, if you have a car traveling at 60 miles per hour and it accelerates to 90 miles per hour in 3 seconds, what is the car's acceleration? So you take the final velocity, which in this case is 90 miles per hour, minus your original velocity, which is 60 miles per hour, all over time, which in this case here is 3 seconds. So 90 minus 60 is going to give you 30 all over 3, so that's going to give you 10 miles per hour per second. So you can see this in graphs. So this graph here has a positive acceleration. So if you notice, the line is going up in a positive slope. This one here is going down in a negative slope, so that's going to give us a negative acceleration. So think of like braking. So anytime you put on the brakes of a car or a truck, you're slowing down, so that gives you a negative acceleration. So here, a car traveling at 60 miles per hour slams on the brakes to avoid hitting a deer. The car comes to a safe stop 6 seconds after applying the brakes, so one is the car's acceleration, where the final acceleration here is 0 because we came to a complete stop. The original is 60 miles per hour, and how long did it take for us to stop? Well, it took them 6 seconds. So 0 minus 60 gives us negative 60 divided by 6, so it's negative 10 miles per hour per second. So a constant acceleration produces a straight line or linear slope, so rise over run. The slope of a non-linear velocity time graph will predict an object's instantaneous acceleration. So here you see that acceleration equals velocity over time. So we can pick a point. So at 1 second, we know that they are traveling 4 meters per second, so that's instantaneous. So that's at one particular point. So when we talk about free fall, so the constant acceleration of an object moving only under the force of gravity, or g. So acceleration caused by gravity is 9.8 meters per second squared. If there is no air, all objects would fall at the same speed. So it doesn't depend on mass. So after 1 second of falling, or it's at 9.8 meters per second. After 2 seconds, it's doubled to 19.6 meters per second. After 3 seconds, it goes up to that 29.4 meters per second. So Galileo, so in the 1600s, he studied how things fell. He didn't have a good clock, so he didn't have a really good stopwatch or anything like that. He basically just rolled balls down an incline, and he found the speed increased as he rolled it down the ramp. So from the starting point to the middle point to the end, the ball constantly increased. Alright, so here we can see acceleration equals the change in velocity over time. So this could be t0, which equals 0, so this is your starting time. We can count this as t1, so this is after 1 second. This can be t2, which is after 2 seconds. And t3 after 3 seconds. So if you notice, the spacing between them is constantly getting larger. So because that space between them is getting larger, we know that their acceleration is increasing as time goes on. So the same thing happens when things fall. So you see if we start here, After 1 second, 2 seconds, 3 seconds, 4 seconds, that gap increases. So air resistance will increase as it falls faster. An upward force on the object, eventually gravity will balance with air resistance. So we call that reaching terminal velocity, which is the highest speed reached by a falling object. So basically what you're going to see is your air resistance is going to be pushing you up. Air resistance is pushing up on an object. Gravity is pushing down on an object. And when you reach terminal velocity is when they basically balance each other. So you're not going to get any more resistance. You're not going to get any more speed from the gravity. And we call that your terminal velocity. So force of gravity is constant. It does not change. It is constant. So we know what that number is, and it does not change. So air resistance increases as you speed up. Until the force is equal. So this here is our gravity. This here is our air resistance. So we saw that increasing until it matches our gravity. And therefore, if both forces are equal, there's not going to be any more acceleration. So that's how we get to our terminal velocity. So acceleration is defined as the rate of change for which of the following. So acceleration is the rate of change for your velocity. An object is accelerating if there is a change in speed and or what? Remember, we need that change in direction. We have to know which way it's accelerating. So what is the acceleration of an object if it goes from a velocity of plus 40 meters per second to rest in 6.2 seconds? So we have our ending. So we have 0 meters per second. We're going to subtract our starting, so 40 meters per second, all over time, which in this case is 6.2 seconds. And when you do the math, you get A, negative 6.45 meters per second. So what is the average acceleration of a snowmobile that goes from rest to 10 meters per second west in 4 seconds? Take the direction west to be positive and east to be negative. So in this case, we're ending at 10 meters per second. And we started at 0 meters per second. And it took us 4 seconds to do so. And so when we do out our math, we get D 2.5 meters per second squared. So which of the following has no acceleration? A person running 100 meters across a field at a constant speed, a car making a turn at constant speed, a person running once around a track at constant speed, or a satellite orbiting at constant speed. And the answer is going to be A. Okay, so if you have any questions, please make sure that you come to office hours after science class to get help. And thank you so much for listening.